Hello, everybody. Wayne Parham, Lone Star Audio Fest. And I'm also with Pi Speakers and a few other audio related companies, like audioroundtable.com and the Pro Sound Shootout. Um, we're coming up on the 4th of July weekend, celebrating the 250th year that America has been a nation. And so I didn't really think that it'd be right to try to get some of the other people. We've got a queue of people ready to do interviews, but I thought this is a weekend everybody needs to go off and do stuff. But I thought, okay, well, to fill in the time, I'll talk to you about Pi Speakers. And I'm not going to interview myself. I'll just start talking. It'd be cool to have. I thought about having my wife do it. That's a lot of fun. But about 15 minutes in, she'd be tired of all the geeking out. So I'm just gonna chat. Where I can start is kind of ironic. It would go back to the anniversary, the 200th year celebration of America being a nation in 1976. Now I was a boy then. I wasn't, grown up yet, but I had already started an interest in audio, and how that worked for me is, I had a little stereo. My folks had a stereo, but mine was, kid stuff, and I wanted a little better quality. I hadn't started working yet. I would get paid to cut the yard for my folks, so I didn't have a lot of money, but I could buy, inexpensive drivers from like Radio Shack. I hadn't yet found McGee Electronics, but that was right around the corner. And I mean, in that, this, we're talking like I'm 14, 15 years old. I'm not even able to drive yet, but I was interested in getting a little better sound out of my stereo. So I don't remember exactly what or where, how I got the drivers, but I started getting, little 5-inch, 6-inch drivers, listening to them. I'd get some car speakers. And I learned a little bit about what I liked. I learned a little bit about, I learned to be curious, actually. I didn't know why these drivers sounded, so different. I'm like, what is causing these things? So then, I also, one of my hobbies was flying planes, the little, Gillows models that you could build out of a kit. And so as I got pretty good at making those things that would fly, some of them would be rubber band powered and some would have a little bitty engine. You could get little engines, not very much money back then. Little Cox was the name of the brand, COX Cox. And I wanted radio control, but that I really couldn't afford. Back then, radio control airplane was a pretty big, expensive hobby, and I'm a kid. So I thought, well, I want to learn about that too. I'd already started tinkering with other things besides speakers. I'd take apart a console stereo or something that my grandparents had given me. I'm playing with electronics, and I'm starting to learn things. I'm starting to read about it as I'm interested. And I wanted to build a radio control for my airplanes. What happens is that segues me into digital electronics, because in the 70s, that was where everything was going. You had TTL, transistor logic chips. You had CMOS chips, the low power stuff, and those became building blocks. And so my focus shifted from the radios and the airplanes into making circuits that did things. And this was also the era when Star Wars, the movie, had come out. So I had a huge fascination with those robots. And I kind of intuitively knew we're nowhere close to C-3PO. But R2-D2 is something we could make. And I remember a Byte magazine article way back in the 70s that I still remember like it was yesterday. It had a little robot called Newt, and it looked like R2-D2. It was an upside down trash can with wheels, but it could plug itself into the wall. It could find a wall socket using its camera and scale that to size, and it wasn't using a neural network, but it was doing something similar. It was having to scale the size and use some fuzzy logic to know, okay, that looks kind of like a wall socket. Let's go at it. Now I know this isn't loudspeaker, but I wanted you to hear a little more about all of my background. Because I think it's important. It shapes where I went with my loudspeakers. So I was interested in all that kind of electronics, and I had taken the time to learn a little bit about reactance because you had to make a crossover. I didn't know much. I'm still a kid. All I really could calculate was reactive impedance. I could have calculated phase, but I didn't really. I don't know if it's that I didn't understand what it was about, but I didn't consider it yet. All I knew was that like capacitive reactance will increase the resistance. It's not really resistance; it's impedance, but it will reduce that tweeter you're trying to cross over. It will reduce the energy down low so you don't blow the thing up. And somewhere around here, I got my first little job. It was at Der Wiener Schnitzel of all places in Tulsa, Oklahoma. And that gave me enough money to buy some parts, not much parts and not good parts, but parts. And the first one I did, I had found a closeout from McGee Electronics on some woofers, some 8-inch woofers, and they were actually they had come from Bose 301s. I guess Bose had changed the woofer that they were using, and they were just dumping these things. It was not a high efficiency woofer, but it wasn't real low either. I'm going to guess it was probably around 89, 90 decibels at 1 watt. And they were made to go in a little two-way, so you could cross it over fairly high and it still sounded good. One thing that I had seen and heard when I'd walk into Radio Shacks, because I love going there, to get parts and whatnot too. But I had seen they had this thing they called a super tweeter. And what it really was a little bitty horn tweeter with probably like a 1/2-inch diaphragm, but a compression horn. And this thing was tuned for like 5K to 20K, actually probably 40K. It was nuts. It was nuts high. It sounded like a rib. And it had really good efficiency, but it couldn't handle any power. You needed to cross it over really high. And so I really liked the sparkle of that. I liked ribbon tweeters when I heard them, like Emmett, the Infinity Emmett tweeter. And I liked this little horn tweeter because it also had that spark. I'm a kid, so I can hear really high frequencies. I walk into a place where there were TVs and I could hear the flyback transformer. Some of you might remember those. That 15,000 hertz sound was deafening to me if you'd walk into a place with a bunch of TV sets. So, I'm sure I was hearing out to 25K, at least that air, I could hear it. And so I like those tweeters. Thing is, though, that 90 decibel woofer and this compression horn tweeter was probably, well, it was at least 100 decibels. And so there's a mismatch. And I didn't compensate for that in that first speaker. But since I crossed it over rather high, the stock crossover was like a second order, probably 8K. And I remember playing with that and trying a first order, which then of course made it, less able to handle power because it got more low frequency. But anyway, since I was crossing it over high, I was playing with those parts and crossing it over high. You could kind of get away with that fact that the tweeter was too hot because I was just using it like about 10K. So they sounded okay. I liked them. Another thing I didn't understand yet was box tune. I could see that, speakers, different sizes, different port lengths. I hadn't quite put together yet that was very similar to the electronics properties of inductance, capacitance, and resistance that the electromechanical parameters of the driver are a tuned circuit. but I could see that there was something there going. What I think I did was to actually, in the very first one, was to just copy the box of the Bose speaker, knowing that that worked. Probably about a cubic foot, and it had a little bitty, like 2-inch diameter port. Anyway, I did become interested in learning what and why do I need to know about the box. And Teal Small had been around a little while, but it really wasn't in America. I think you could probably find it, but it was hidden. It wasn't something you'd find in any hobbyist magazine or anything like that. It was Australian. It just wasn't here. You didn't even, when you would go buy a driver from someplace, it wouldn't have Teal Small specs. It would have no electromechanical specs. You'd be lucky if it had a power handling uh, figure. And if it had it, it would be wrong. It would be grossly exaggerated. So there was really nothing published in anything I bought to go on. I had to try to figure those out myself. But I had started to study more about the electronics and reactive formulas. And so I did kind of realize, okay, there is something similar here. And I cobbled together some formulas that later became what I called PiAlign. And they were modeled basically after electronics values and frankly kind of guesses. And I got pretty lucky because it was close. It was close. In hindsight, it was close when your driver's Q was close to 0.38, or actually 0.375, 3/8. That's where when you plugged in a driver with those values, the box and port it spit out were pretty good. Slightly overdamped, but not much. As your speaker was more and more high Q, then the calculations didn't work as well. It'd kind of make an EBS alignment. If your driver was overdamped, if the Q was really low, it would also make it would be more and more overdamped. But the box sizes were reasonable. And like I said, when you're around 0.375, the things were good. And where I got lucky with that is this. I had stumbled on JBL Professional Series drivers. And I'm jumping forward a little bit here. But I will say this before I back up. The JBL Professional Series stuff is all around 0.35. So ironically, that was a lucky hit. My formulas with the really good JBL 2200 series, Professional Series drivers worked well. So now let me back up a second. Another thing happened to me that was really cool, but this goes back into the computer stuff. I told you that I was all into digital and I was making little circuits that would do, just a variety of things. But not computers yet. A clock going into a counter circuit that I could blink lights on or something. But I went to church in a Methodist church in Tulsa. My folks, took us, the whole family there every Sunday. And I met a man named Mike Nett, and he was an electrical engineer. And he worked for a company called Global Data Systems in Tulsa, Oklahoma. And they were an OEM for data jet. Now, I didn't know any of that. Now I'm 15. I'm getting real close to driving age. And so he kind of took me under his wing. He showed me a lot of stuff about mostly digital electronics and even computers. Somehow or another, he had found he had an 1802 processor, little board that had 256 bytes of RAM, and the input was switches. So you had to enter data in binary. But like other 1802 processors of that day, you actually could, make that work with the display. You could enter data fairly easily. It wasn't a complicated circuit to enter data and get data out of a little 1802. That was made by RCA. They weren't a popular processor, but I do believe because they were a low power CMOS chip, and I think that was in the Voyager, the ship that we sent out in the 70s, and that thing now is like a light day away. Been 50 years, and it's now so far that it takes 1 day for its transmissions to get back, and the thing is still running. And I think it used that 1802 process. But anyway, so Mike teaches me about, I'm like wondering, how do you use numbers and tell it things? And he made the analogy, well, it's like a grocery list. If you gave a number to every item you wanted and gave a number to instructions like turn left, turn right, go down this aisle, that is your instruction set. That's essentially how the computers work. They define, go to this memory location, add this number. Those are all each instruction has a number. Okay. So I could program that little 1802. And he got me a job at Global Data Systems in the summer, full time. And I'd build circuit boards that were little, essentially embedded controllers that would talk to a data general mini computer, and they would do something for the customer that Global Data Systems had solicited. They're building this controlling system for them. Yay. Now I'm in the world of computers. I'm 15. There was a full-time guy there that was coding using a system running CPM, probably a Z80 processor, and he would write microcode for the embedded processors that they attached to the data general systems, and those would be, for gathering data acquisition, and anyway, so I got to be around all that. It also gave me a paycheck, and I learned a lot about computers in that time. So then, also, actually, when I was 16, just after that, at the end of the summer when I was 16, it's 1978, and I really wanted a computer for my birthday. It's still kind of expensive, but my folks had talked to Mike and they got me this thing called a SYM-1, which was a 6502 based machine, and it was built by Centertech Systems. 6502s were made by Moss Technologies and Centertech, and Moss is who made the KIM-1. That was the very first 6502 based computer. Then there was my SYM-1. It was also early. And of course, as everybody else knows, the Apple I and the Apple II, those were 6502. And now, again, I know I'm getting all into computers, but this connects to the loudspeakers in a way I'll get to in a minute. What happened was, I had that SYM-1, and it was really a wonderful little computer. I could program in BASIC the formulas for that loudspeaker calculator I told you about, the PiAlign, and I could use my computer to calculate boxes now. I had worked at Global Data Systems, and then during school, my little after school job, I'd worked 4 hours at Radio Shack, so that's perfect. Selling diodes and triodes, and whatever, stereos and whatnot. So I had a little bit of money, and that's why I could afford to get those JBL drivers. I had to save up to get them, but that got me in a whole different league. And the truth is, I was really impressed with Klipsch during this time too. I liked Infinity because of their image tweeter. I liked Klipsch because of their horns. And I liked the JBL Professional Series stuff because of its just high quality, low distortion. They're wonderful parts. I still use them today. And so that all put together, and I cobbled together my first constant directivity corner. And it probably wasn't really a good constant directivity, but it sure had good parts. And you put it in a corner. And I still make that speaker, of course, with a lot of, a lifetime of improvements. But that was modeled off the Klipsch horn. But I didn't really understand acoustic loading yet. What I did understand was, well, it's not even really directivity, but it was boundary reinforcement. I knew that if you took any speaker in free air and then you moved it towards a wall, it got louder. And then if you moved it again towards a wall and say the floor, it got louder again. And if you moved it to the apex of a corner, that was the loudest place. And in some situations, some rooms with some drivers, it actually sounded pretty good that way. There's stuff that doesn't, of course, we all know that. But I was intrigued by that. So I take this JBL 2205 and I put it in a box that PiAlign had determined it should have, which again, as I said, was pretty well right. It's slightly overdamped, which is what you'd want. Man, that thing was great. I used 2105 mids, which is a 5-inch mid, and I'd make a little truncated array, a couple of them. Of course, that left me with problems with the tweeter. I always back then had trouble with the tweeter. I didn't like the horn tweeters back then. The compression horns they just didn't hit the high notes. So I played around with different tweeters, and including that little Radio Shack super tweeter, and I even tried the Pizzos for a little bit, which were kind of okay for just the frequency range they were being used in. But man, I put together some great speakers. But of course, being in the corner isn't the whole picture. They sounded really good. They sounded a lot better than they had a right to sound. But I did start to study more about real horns, and in particular, constant directivity horns, because, I was infatuated with the wall, which is kind of a constant directivity horn if you do it right. It doesn't have my boxes don't have a compression chamber. So it's really just a boundary effect thing. And of course, room modes come into play. So until you get to at least 200 hertz, directivity doesn't make sense. But if you've got a driver and it is acoustically close to the apex of the corner, then from the Schroeder frequency up, it's constant directivity. And so I looked for horns to give me that. What I found though was two problems. One is, like I said, way back then, compression driver horns, I didn't think hit the high notes. So that was trouble for me. And another thing was a CD horn of that day sounded kind of, I'd call it spitty. I'm not usually an adjective guy, but I'm just trying to describe that the crash of a cymbal wasn't crisp. It was smeared, and I didn't like that. So I had to play around with that for a little bit. And what I even tried two ways, which was not the greatest thing, because then you're pushing the woofer too far. But I did eventually come into what I have now, which is a true mid horn with compression chamber. And I use as you guys know, probably a waveguide tweeter horn that isn't spitty. I was using radial horns for a while, because I didn't like multi-cells. They're cool looking, but I preferred radials with a 90-degree angle because they gave me pretty close to a uniform 90-degree pattern in the horizontal. The vertical collapsed, but it wasn't terrible. And so that worked for me for a while. And then later I graduated to starting with PVs, the quadratic horn waveguide that Charlie Hughes invented. And then, Geddes was pushing the oblate spheroidal throat. And, well, he pushed the whole horn being oblate spheroidal. He also suggested prolate spheroidal if you want an oval, or elliptic cylindrical geometries if you wanted a rectangular mouth. And so, that's what my stuff is now. It's the tweeter horns are all oblate spheroidal in the throat, transitioning to elliptic cylindrical in the mouth, and that way I can get a rectangular horn, which works well for a lot of reasons. It gives me the coverage I like. It's easy to package, and they just sound great. But I've jumped way forward on that. The back when I had built the first corner horns and just kind of got lucky, another thing happened. I had entered a contest that now I'm back to being a kid. I'd entered a contest that IBM did. And they were looking for engineering talent. You know, people coming up. And the prizes when you win is you could get an oscilloscope, you could get college scholarships, and I entered this thing, and they had it in like levels. You'd do it in your city, I think in your region of your state, and then national. And I just killed it because I'd already studied so much. You know, they'd tell you to design a like a little amplifier. They'd tell you what transistor you could use, and you had to pick the right resistors to bias it up. And then you had to actually build it, solder it up, and show a signal generator, and to provide an input, and then use an oscilloscope to show the output and show that it worked. Then you had to make like a debounced switch, stuff like that. So at the state level, I just smoked it. I mean, this was a 3-hour long thing. I got done in 30 minutes. I had to build like 3 or 4 circuits. They were all perfect. That one I just smoked, and I was kind of surprised. I thought I'm okay with this stuff, but I had no idea. I mean, I'm like waiting around for 2.5 hours for the other guys to finish, and then, you know, their 3 hours is up and they're done and wherever they're at. But I got first place and I went to nationals. And at nationals, what happened was IBM, in fact, I'm going to show you here. IBM had designed an 1802 processor for this contest. And honestly, all you had to do was assemble it and program it. And you did the thing that 1802s do, put in this little program and made the Q light blink. That's what every 1802 guy did back then. What I didn't, well, here's the little thing. This is funny. This is IBM's very first. This was their very first microprocessor. It's and there's my entry number 28. This is what it looked like right there. You can see it's got entry hexadecimal keypad. It's got the screen. This is like your enter button. Then it's got load, run, and protect switches for your memory. This thing had 256 bytes of RAM, an 1802 processor, and there's your power plug. This thing still works, by the way. All these years. What happened is this. I didn't know, but IBM circuit boards. Any real IBM guy will know this and tell you this. Back in the 70s and probably in the 60s, I don't know, but they made their own proprietary circuit board, and it was different than most that you'd see. Most that you'd see, well, they just look different. The lands can be any different width, and you know, they're often, you see them these days. They'll have a green solder mask, so they have a certain look. They usually have you know, a silk screen layout that's white that tells you what parts go where, and IBM didn't do that. Theirs looked like just that cream colored fiberglass board with these little bitty tiny black traces, little bitty ones. So old IBMers, if you ever hear them talk about popping a trace, it's because they're so small they can't handle any current. Anything goes wrong, it pops it. So they'd have to find it and resolder it. But what I did on this computer, the keypad had like, I don't know, 8 outputs, and every segment of the display also had, it didn't have 8 outputs, it had 8 pins. And every segment of these displays is like, I think, 8 pins, because it's a 7-segment display. So I guess you need 9 pins. You need every segment and the power and the ground. No, you just need the segment and a power or a ground. Anyway, it's a lot of lines, a lot of wires going from that the front panel down to the processor. Lots of wire. Well, I redesigned it. It was faster to me Plus, I wasn't really paying attention that, you know, you've got these traces there. I redesigned it to where I had the encoder and driver circuits on the board that holds the lights, the 7-segment display and the keypads. And then all it has to do is run down to the processor using its little data bus and a couple of control signals, and boom, you're done. It was a better design, and it was easier and faster for me to get done. So boom, I'm done. I win. No, I didn't. IBM disqualified for that redesign, even though they privately told me that it made a lot of sense and they were impressed and they offered me a job. So that said everything, but they disqualified me for that. But then what also happened was there were a couple of computer companies there. I don't know why there weren't more, but it wasn't just IBM. I think they were a big sponsor, but Data General was there too. And I told you the Global Data Systems was a Data General OEM, but I didn't know that at the time. I just knew Mike McNatt had this cool job. I don't know anything about Data General yet. But in hindsight, I'm surprised DEC wasn't there, Digital Equipment Corporation, and CDC, Control Data. Burroughs, I'm surprised that all the big players weren't there, and maybe they were. But what I knew was I still was offered scholarships, and I was offered jobs from IBM and Data General. They wanted me to work as an engineer, and I didn't really want to work with IBM. They were always wore black suits and black ties and a white shirt. Data General also wore suits, but you might wear blue. You might even wear green. They were a little cooler back in those days, in the mini computer days. Data General was the Apple. You know, they were like Apple. They were a little cooler. IBM was pretty stiff. Well, all that to say, I was able to start working fairly early, and that made me a lot of money as well for building my loudspeakers. That helped me to fund my loudspeaker development, but it also meant I wasn't going to use loudspeakers as a career because I was doing too much better in computers. And I worked for Data General for a couple of years, and then I ended up starting my own business, designing things like the control systems for McElroy Manufacturing in Tulsa. They make a pipe fusion welder. They wanted to computerize it. I made the gear for them to sell, you know, in their pipe fusion machines. Chittum International, they made cooling towers and cooling tower parts. I could computerize that for them. They had done all control systems were pneumatic. That's what would control the louvers of the cooling tower or the pitch of the fan. They really wanted to enter the 80s, the high tech. And so they had me design them a computer controller. And that was easy. You know, I just would use a Intel processor, code it in C, microcode it so that it would be a dedicated controlling device that would control the louvers of their fans. I had Whirlpool. They had a plant in Fort Smith, Arkansas, which I think later ended up falling kind of like to the Aaron Brockovich thing because I think they had hexavalent chrome in their pipes. Everybody did. That was what you used to treat them for rust. But that factory was running in the 70s and 80s, and they wanted to computerize the line, and I designed a communications board for some TI mini computers so that they could do that. That was a cool story too. I won't get into it, but sometimes in testing that, I would have to cross a line. Sometimes they'd have a strike, and I didn't know. You don't go into that building when there's a strike. I thought, well, this is a convenient time to go in. The line is down anyway. I can go test. Well, you don't do that. That's fun. I do that. And then Walmart. You know, I'm in Tulsa, but Walmart is only 2 hours away, and I had a friend that had gone to work there, and he would tell me when they had trouble connecting they had Series 1's mini computers in the stores connected to all of those 4680, which are now 4690 cash registers. And then they had handheld scanners they wanted to connect for like inventory and everything, telephone units. Whenever they had something they needed and they couldn't get, he would ask me if I could do it. Of course, I'd design it, because if I design one, build the little prototype, and the project succeeds, I'm going to build tens of thousands of these things. So I made for them RS-232 to RS-422 converters, a NiCad charger that was smart enough to only charge when something needed it and do the full cycle. If right before it charged, it would deep cycle it down. That was brand new back then. Nobody really did that, but Walmart was spending like $11 million a month on batteries because the NiCads would die because they'd use the thing for 10 minutes and put it on the shelf and it'd kill the NiCad. I made some telecom stuff for them, that just all kinds of stuff for Walmart. And so that let me really spend money on audio. And even though it wasn't something I wanted to do for a career, I sure wanted my stuff good. And so I did study it on the side so that I'd know, what am I doing here to make these as good as I can. And I learned about directivity. I learned about the diffraction in those CD horns. And I learned part of the reason why those corner horns were so magic was, and I learned this from JBL. I think Earl wrote this paper about the 4430 and the 4435, which had a JBL, I think, in 2205. It was very much like what I now call 4-pi, JBL 2205, and then it had that big constant-directivity horn that everybody calls butt cheeks. I forget the number of that, but they described and Earl, I think, described it, when you would point them inward 45 degrees, you'd get that trading effect of, if you're anywhere in between these speakers, you get pretty good imaging, you get pretty good stereo balance. Because if you're nearer, let's say you're nearer to this speaker, well, then you're far off axis. You're looking at my hand here. You're off axis, but you're closer. And then having them angled in like that, if you're the one that you're closer to, your sound level increases because you're closer, but you're far off axis because of the angle of the speakers, and vice versa. And so what that did is make it where pretty much no matter where you sat between those two, if you're behind where the axes cross, you get that balancing trade-off, and you get stereo balance that both sound about the same. So imaging is good. And I was like, wow, that is exactly why those corner horns are so magic. And so, I began to set up that way eventually, not just my corner horns, which were a happy accident, but also the little two-ways that I made, that had first a 2205 and then a 2225, and now the current models have 2226. They're all very similar. That and a waveguide horn with the compression drivers nowadays that can easily hit 18K, and that's getting good. I like those. And so that makes my line. And now let's go way back to when I was a kid. You can see how the line progression is. I'd started that just on a lark. The way I did it was, if it was a box speaker and it had a 8-inch woofer, it's a 1-pi. 10-inch woofer, it's a 2-pi. 12-inch woofer, it's a 3-pi. And a 15-inch woofer, it's a 4-pi. Then, back then, corner horns were 10-inch woofer is a 5-pi. 12-inch woofer is a 6-pi, and a 15-inch woofer is a 7-pi. That's it. That was all the thought there was to it, and I still do that to this day. But then that also gets me to the mark itself, pi speakers. See, way back, I told you I'd studied Reactance pretty early on, and I didn't fully understand, but I did know that the formulas I needed to use all had pi. And I'd seen the Infinity brand of speakers. I loved those. And I thought that was cool. A mathematical symbol is the name of their company. Those were the influences. That's why I named my company Pi Speakers. And it was really good. I mean, that's a great branding. I got lucky on that. To me, it was just cool as a kid. It's still cool now that I'm an old kid. But it also was a great branding because I have the federally registered trademark for the pi symbol and for the word pi in class 9, so in electronics. And I police that. I mean, if somebody makes a mistake and they build a loudspeaker or something where there's brand confusion, I have to go after them if it's or an amplifier even. I kind of limit it to audio. I know there's no brand confusion, like for example, in the computer Raspberry Pi, plus they're British, but there's really no brand confusion. So I was never worried about them. But I've had several loudspeaker companies want to be Pi speakers, and then I have to go approach them and I go, oh, sorry. Especially before the internet. It doesn't happen so much now, but before the internet, it happened a lot. And I've had an occasion or two where a company would name an amplifier Pi, and that had to get too. So, but anyway, I want to talk a second about the subwoofers. Most of my career, I did not like subs. I mean, not for home hi-fi. And I certainly didn't like the two little speakers on a pole and one sub. I didn't know why. I thought it was just the quality of the drivers I was using were better than the stinky subs. Well, I learned I was wrong about that around the year 2000. A lot of stuff happened for me around then. But since I've already started talking about the subs, I'll continue. I read that paper from Todd Welti about the 5,000 subs theoretical and how it made, it essentially makes the modal region of the room act just like the reverberant field. It would become a reverberant field. And it's when I read that I just intuitively he is right on. And then he describes a way to do that with a real number of numbers, usually 4. He described either putting them in 4 corners, 4 wall midpoints, or he has one where it's 2 wall midpoints. That probably works well. I kind of don't consider it, but I did like the 4 corners. That worked great with my cornerhorns. And I liked the 4 wall midpoints. That works real well too. And then I met Earl Geddes, wonderful guy. And he had a couple of things that were attractive to me. One was his work with the waveguides, the oblate spheroidal geometry for making the flare profile, basing it on the oblate spheroid. It's very similar to Charlie Hughes' quadratic throat waveguide. And so, I mean, I began to adopt that right away. But also, Earl had the idea that Welti, that he felt that it could be improved. That instead of having them in 4 symmetrical locations, Geddes proposed, I believe it was in the beginning for him, it was 1 in the corner, 1 at a midpoint, and 1 at a pseudo-random location that's not, either a corner or a midpoint. And he even, I think, proposed that third one be in not just in a different place along the horizontal plane, but also offset in the vertical. To be honest with you, I thought, well, that's pretty cool too. But I did kind of think if we really want to get down to that level, we might measure stuff. And because we're looking at nth degree type of stuff. Because one thing both Geddes and Welti agreed upon, and it seemed intuitively correct to me too, is that once you get to 4, once you got 4, it almost doesn't matter where you put them, as long as they're not like right on top of one another, to where there's really a single sound source. It almost doesn't matter where you put them, but you can dial it in a little better with measurements. And I think both agreed with that. Then here I come. I had one other extra thing. I had measured a line array for Fred Thompson, who was very regular at the Lone Star Audio Fest in its early days. And I saw him last year too, and I was very pleased to see him and very sad that his wife Linda had passed. But he was very active on Audio Roundtable, my message board. I'll talk about that in a minute. And he was very active in the Lone Star Audio Fest, which was initially in Tulsa and called the Great. And I was measuring an line array for him that he called art arrays, which was named that because of AudioRoundtable.com. We were doing a lot of group builds back where people could gather together and make group purchases to get the prices lower, in some cases to get parts at all, like group builds for an amplifier, a tube amplifier. You might need a custom wound transformer. And I think they were using Haybor. Everybody was using, one of the winders, maybe MagnaQuest. But point being, I was measuring some arrays for Fred Thompson, and I noticed something that I'd seen before, but it was a light bulb moment for me, which is no matter where you put the microphone vertically, kind of doesn't matter. That line array doesn't get a floor bounce notch, because where there would be a notch for one driver, that frequency, there's not a notch for any of the other drivers. So if you got 4 or 8 drivers, their notches are at any one driver might have a notch, so it's gone at a certain frequency because of the self-interference notch from the floor, but only like 1 of 7 has gone. So if you do the decibel calculations, it's losing like a half a decibel. It's gone. And I went, okay. So that approach could also be used when you got a speaker like my 4-pi or my 3-pi. It's a 2-way on a stand, and you're angling them in. Let's make this a part of the multi-sub configuration. I can do what you all probably already know. I call them flanking subs. I used to call them helper woofers. And I borrowed that from the JBL 4435, which I already mentioned. The 4430 was a 2226 in butt cheeks. The 4435 was 2 2226s, or actually 2205s. The second one was used only up to 300 hertz, and it filled in where the baffle step was. So I was like, okay, I'm going to take those approaches and borrow all of them and wish them together and make a helper woofer, which I later call a flanking sub. The helper woofer would be just like the 4435, 2 woofers, but I'm taking that second one, putting it in its own box, and I'm going to set it a little bit beside, behind, and below the mains. Don't put it right under it. Don't put it right beside it. Put it offset in all 3 planes, because then I get a little bit of the effect that line array that Fred Thompson had designed. I get a little bit of that mitigation of the bounce, SBIR. I don't get as much of a notch off the big one as the wall right behind the speakers, because we all got to live in our homes. We can't pull our speakers out in the middle of the room usually. Big pockets guys can if they got big rooms, but most of us have our speakers kind of close to the back wall. So every one of us has got an SBIR notch right off that back wall. And since they're usually, not right up against, you can't get right up against the wall because you're not going to, have the baffle be flush with the wall. So you're usually something like 1 to 3 feet from the back of the wall. And so everybody tends to have a notch between like 80 and 150 hertz. And it's because of that. It also would help you if you had a nearby sidewall. The corner horns don't fail that because the woofer is acoustically close to the corner. So the woofer doesn't suffer that. It's just exactly the same as if it were flush with the wall. But, a loudspeaker cabinet's big enough it prevents that from happening. They're acoustically a little distant. And especially as you get to the higher end of the range, when you're in the lower mid-range, that's where this problem occurs. So, yeah, I loved Welti and Geddes multi-subs, but I realized you can't run a multi-sub up past maybe 60, 80 hertz because you'd hear vocals in it if you did. And so I began to develop the idea, well, let's take a couple of those subs and let's put them right by the mains as flanking subs. They'll mitigate SBR, they'll mitigate SBIR, they'll fill in baffle step if you get everything sized right. And instead of being a helper woofer, let's make it a true sub. Because we're only going to go up to like 200 hertz. Anything can do that pretty much. But we can get a sub that gives us the deep notes too. All three of those things happen. I just like, wow, that's cool. And so that's where the flanking sub comes from. And it is adjunct. It's an adjacent adjunct thing to a Welti or a Geddes multi-sub. You use them in tandem, and the flanking subs become two more nodes. Now I'm going to step back a minute about Y2K. I said a lot of things were happening. One thing that happened was, as I told you, the audio roundtable, and I formed that message board, and I began as a part of that, the Great Plains Audio Fest and the Lone Star Audio Fest. I told you about that. What was going on was, in the late 90s, I had put plans for some of my models of speakers online just because I thought it was cool. It was totally hobby. I liked my stuff. I had made good stuff for me, and I wanted other people to enjoy that too. I noticed some message boards were picking them up. And back then, message boards were still, it was barely past the days of America Online and CompuServe. The internet was really thin, and I liked it better back then. It wasn't quite as thin as the early Data General days, where it's still DARPANET and there's only like a few dozen systems. There's Data Generals and there's DEC, and that's it. Back then, the chats, of course, were very thin because it was just people in universities. Now, by the time the internet had opened up and the HTTP transport was developed so that you had like websites and links, and message boards began to spring up in the 90s. By that time, it's not quite as thin, but it's still pretty thin. But I noticed people were talking about my speakers. And so I would introduce myself on a couple of forums. I kind of didn't like that. At first, I thought there's no fun to be had on the internet. It's better to go out and drive your car and hang out with your buddies than this. But when I saw him talking about my speakers, I thought, well, I'm going to introduce myself. And I did. But what I found was, those early message boards, sometimes they could get a little nasty. There were some kids that weren't playing nice. And I found that I don't react to that very well. I don't like it. And so I quickly moved away from some of the message boards. There were two in particular that were really foul. There was one, a Pro Sound one, that had all kinds of shenanigans going on. And then there was a Home Hi-Fi one that was pretty bad too. Some of the others weren't so bad, and I would hang out a little bit there, but I ended up opening my own. I opened up audioroundtable.com, and it was specifically because I wanted to make sure to, number one, honor people's, what is technically a copyright, even though it maybe isn't registered. If someone writes a post on audioroundtable.com, it's theirs. They're giving me a license to display it by virtue of the fact that they put it there. But I treat it as theirs. If they decide they want to delete them all and run away, okay, that's fine. They can do that. I will let them do that. And I also don't allow any shills or sock puppets, is what we call them back then. Someone posting as someone that they're not. You can have a anonymous username, but you can't have 3 or 4 of them. And because I was seeing a lot of that stuff happen at some message boards, and it was pretty bad. I won't get into it. You don't need to hear it. But what I will say is, that was the beginnings of Audio Roundtable. And the message board, or the little trade show, was an offspring of that. The Great Plains Audio Fest, and then later the Lone Star Audio Fest, were tied to Audio Roundtable. There were everybody was invited. And there were other message boards that some would hear about it and come as well. But we were originally intended to support the sponsors of Audio Roundtable, who are all little companies like Pi Speakers. They made kits, amplifier kits or other loudspeaker kits or something. And then eventually, there were small kit manufacturers that weren't associated with Audio Roundtable that came. But in the beginning, it was all Audio Roundtable and many hobbyists, like I told you about Fred Thompson. If they do a group build, we'd have a place to let them show that at the Great Plains Audio Fest or the Lone Star Audio Fest. It was really cool. But yeah, a lot of folks were coming from other places, but it really did cater to companies that had a online presence, but they had no showroom and no dealer network. So how people would buy their stuff sight unseen. They often would buy mine that way too. Some people would fly out to see me. That's wonderful. We'll have a coffee and listen to some music. But by golly, that's a lot to do to come see and hear a speaker. It's almost better. It can almost cost less to just have a cabinet maker build your speakers and listen to them. And if you don't like them, sell them. That's almost less money and less trouble than flying out, but some would do that. And so by having this trade show, what that brought to each exhibitor was one weekend a year they could show their gear. And what that brought to the attendees is if you're going to fly out or drive for a day to see my speakers or somebody's amplifier, well, now you're going to get to see like 20 more other products. So that was where we went. And in the early 2000s, when we started it was gangbusters. I will say this, one thing that I didn't see coming really, well, I sort of did, but probably somewhere between 2010 and 2015, we'd transition from the message boards being as popular as the social media. I personally, I mentioned this in one of the early Lone Star videos. I think it was the introductory one, or it might have been the one about seminars. But I never have gotten involved with social media, and I never will, because of the things I saw on the early message boards. If we were having trouble with just a bunch of guys talking about cars, or just a bunch of guys talking about stereos, if that was trouble, how much more trouble was there going to be in social media when you got young teenagers, picking on each other, talking about their boyfriends and girlfriends and the trouble they have there, and they're bleeding out for the whole world to see, and then ashamed of what they've done, and can they clean it up or not? Who knows? Everybody's picking on them. That's what social media was going to be. I knew that from the start, and that's what it's become. And it also now, it's there's not sock puppets and shills just trying to promote some loudspeaker. They're trying to promote politics and other stuff, and it's nuts. I knew that would happen. What I didn't see coming was the message boards getting less and less attention. But the other thing I don't like about social media, and I won't go too far because that's not what this is about, but I do know this because I work in, actually right now I work for the Department of War, and I do some coding. I can't tell you more than that, but I'm intimately involved in artificial intelligence as well. I filed a patent, in fact, for a thing I call a large concepts model. And so I'm plugged into these technologies, but the social media one, see, there's two things I know. One, they mine that data, and they use it to make decisions. And that's not stupid, but it can be done in a way that's not the best. And here's another one I know. those so-called influencers, it's not guys anymore, guys and gals that have something to say. A lot of time a lot of time an influencer is paid. They're just paid to go rack up points, go rack up attention. I've seen companies that their thing, whatever they're marketing or pushing, has no actual traffic. But, you go pay some influencers and it looks like they've had 1 million hits. You pay for that. So there's all of those things that make social media just a pack of lies. And I don't want to have anything to do with it. So sorry, I got all a segue. What I do want to say though is I did not see it coming in the 2010s to 2015 that these little message boards were just getting less and less traffic. Mine still has pretty good traffic. My Pi Speakers Forum, because that's where people come to talk about my stuff. If they want help, that's where they come. So it does fine for me. But I do think that Lone Star probably was adversely affected slowly by the fact that our promotions, which were great in say 2005, were less and less heard. And that's part of why now I'm kind of starting to push this YouTube stuff because, a couple of years ago, two things happened to Lone Star that made me, rethink the model a little bit. And one thing was we bumped into the date we picked just happened to be the same date as the THE show in California. And so I wrote just like info@theshow.com, and Emiko Carlin wrote that. And, long story short, because we're bumping up past an hour here, but she said, we've been watching your show. We think you're kind of cool. And we'd like to maybe talk about partnering, which I immediately thought would be great because even though Lone Star was always perfect for the one-man show, it was perfect for the online company that has no dealer network and no showroom. Lone Star's not perfect for the ones that do. They want a bigger show. And I usually hear little grumbles about, gosh, I wish we would promote this better. And I'm like, well, then go promote it on your own social media channels. That's how we do this thing, is everybody promotes their own stuff. But they didn't like that. They wanted a show that was a little more traditional. And Emiko brings that, and that's what I thought was, well, I'll enter this thing with her. The other thing I like about Emiko is she's a musician, which I think is really cool. I don't know how much connection she has in the pro sound world. I know I have some, but she may have some too. But still, regardless of that, she did and does have connections with the dealers and the little higher end network. What I would really, this is my druthers. Texas is a market that while it is large, it's geographically large and it has a large population. And there's a lot of money there. People are out. They would like, I'm sure, find stereos. But one thing I've noticed about the Southwest, and the Southwest is Oklahoma, Texas, New Mexico, and Arizona. That's what Southwest America is. But I'm going to add also Kansas, Missouri, and Arkansas, because my show has always drawn people from that geographic area. So it's not just Southwest, but a few states more. But anyway, what I've known about this area since I've lived here all my life is that, it doesn't draw the kind of attendance at these shows that say a Los Angeles show would bring. It just doesn't. And yet that market is still very big and very important. So if I had my druthers, we would have a triumvirate. We would have someone that championed the high end, what I call audio jewelry. It's stuff that's, you're spending
$30,000 just on the cabinet because it's that fine. It's Steinway quality or something. And then it also has good electronics. So we'd have someone that approaches that $1 million market. Then we'd have someone, me. I can approach the companies that I've been dealing with. They're a little more techie crowd. They get out their oscilloscopes and their acoustic measurement microphones, and they dial it into perfection. And their cabinets may be nice. They sometimes will go ahead and get that $30,000 cabinet for their loudspeaker. But sometimes they get an MDF box with Trek bed liner. It's a Pro Sound cabinet, and it still sounds as good because it's got the same electronics. I can approach that guy, and I can approach some of the Pro Sound guys. I know, David Lee, Tom Danley. I know some folks, Bill Fitzmaurice. But Emiko is a musician, and so I would love, her input. So there's the triumvirate: the Pro Sound, the high end, and the DIYer. I'd like that to be one show in Texas. Now, what I like and what I get are two different things. I don't know. Everybody's got their own mind what they want to do, but I am saying that's why Emiko and I have partnered. It moves in that direction. We don't need to have too many shows in Texas that hurt. Every show hurts when we do it that way. I think that would be better if we, realize that. But yeah, that brought me to, why there was a Great Plains Audio Fest, why there was a Lone Star Audio Fest. I'll end with this. I mentioned also the Pro Sound Shootout, what that was. And I did it only for 3 years, but I might kick it off again, especially as I just talked about in the Pro Sound leg. Another hobby of mine is cars. I like fast cars, and I like hot rods. And I my dad opened the Porsche dealership in Tulsa in '72, so I love Porsches and that kind of thing. And I honestly snobbed out and didn't think much of the old American cars till I found a guy that knew how to, how those things work, how they, the '60s muscle cars. And then I got to see that ground pound in action too, and I loved it. I love the quarter mile racetrack too. So I started going often. I built myself a little hot rod cutlass, and I'd go to the Tulsa racetrack, Tulsa Raceway Park, pretty often, get time slips to dial in my car, and just, and it's a fun sport. Everybody that's really racing, you're buddies with everybody. You win some, you lose some, and rooting for everybody. It doesn't have it's not as competitive as you think it was. I mean, it is, but you win some and you lose some. So you're always high-fiving everybody. It's a sport where you'd loan your motor to the next guy. It's just cool. I love that. Anyway, I was going out to that track, and then subsequently I wanted to build just a statement woofer. I wanted to build the biggest, baddest, meanest portable bass horn sub I could make. And it was largely in response to Tom Danley's lamb horn. Now, you all know Tom Danley is the man. In Pro Sound, ever since Thermodride days, he is a legend. And he's done several other things since then. He's done that tapped horn. He's done the Unity horn, and then the Synergy horn. Incredible ideas. But the lab horn, he made that horn, and I thought this thing's awesome. But to be quite honest, I thought I'm going to try to improve upon that, and he had misunderstood, but we had some misunderstandings way back when. I actually quite respected him. I do my hi-fi a little differently because it's for hi-fi. But for some reason, he thought I was in the camp of like Bruce Edgar and Edgar Horn, another man I respect a lot. I was very sad that he passed. He's also an Oklahoma boy like me, and he made these wonderful tractor-based horns, round horns, tractors. So they weren't constant directivity; they were tractors. But he was a big deal in the DIY world. The kind of guy, we'd see each other at shows too. But his bass horn, he did use woofers that were fairly low mass and everything. And you know, uh, since Bruce Edgar and I are friendly and kind of in an overlapping field, I think Tom Danley got the idea that I was of that camp. I was not. I had no problem at all with a high mass woofer in a horn. I whatever works. But anyway, I digress as usual. Sorry, this whole conversation is one large digression. I think. But what I wanted to do was to make my horn an improved, basically, lab horn. I saw it had a pretty big dip. Seems like down around 40 hertz, 35 hertz, which is splitting hairs. Once you got 4 of these things together, and that's how it was designed to be used, you didn't have that. But still, I knew if I made it with a little bigger mouth and I could still fit it through a door, which is to me was the main thing, that I could have a little smoother response. And what I also wanted to do was to provide additional cooling. That was another one Danley and I talked about. He with the servo drive, he used a commutated motor, which was cool, so cool. But a commutated motor is really hard to cool. That's a little DC motor. It's a thermos bottle, man. It's got no way to cool. So of course, one of the best ways to cool that is forced air convection cooling. Blow air over the thing. In a linear motor loudspeaker, the kind we have with a voice coil, you do that by making the cone itself just chuff air back and forth. And you hope to, get some cool air in there, not just be chuffing the same hot air. But that's the forced air induction, and they put vents in them, and that works actually pretty well. So what I thought to do was to take, I wanted to put a cooling device in my bass horn, which I call a Pi 12. And this is a style of mine. When I design something, I do it out in front of the world, everybody can see. So I start designing this thing, and I'm first thinking about a W fold, and then the kind of equal angular spiral, kind of like a shell, and that one worked best. I thought it fit best. And then it let me, do the same thing. Have 2 woofers, similar to the lab horn, 2 woofers in there. But what I was going to do is this. I was going to vent the woofer. It already has a vent. And I was going to go through a ducting and an intercooler. And the ducting I was going to borrow from hot rod cars. There's some headers called anti-reversion headers. And basically in the flow path is a little funnel. It looks like a funnel. So the airflow is not really restricted when you're going through this way. But it is somewhat restricted when you're trying to come back this way. It tends to gather up around. There's a high restriction flow this way and not this way. And that's the way the AR headers were made. And I thought, well, I can do that to introduce unidirectional flow. Instead of just chuffing back and forth, I wanted unidirectional flow so that the intercooler, a heat exchanger, would actually get a hot air in and a cold air out. Well, I put all this ducting together, and what I found is that I could introduce unidirectional flow. I could measure that with a little vibrating membrane. I could see, okay, it's vibrating, of course, with the woofer, but it's largely one directional, and that didn't matter at all. The cooling air in a voice coil speaker, the venting works great, but it's largely just because you're just blowing wind past it. It's not like you got a lot of heat buildup. Even if you got a sealed cabinet and you're hitting it with a ton of power, yeah, it's going to get hotter in there. But I was really surprised how that heat dissipates. You're not going to get an intercooler that does it. So I pivoted. I thought, okay, where is the heat? Well, where the heat was that wasn't being dealt with was that which is radiated and conducted into the motor core itself, the pole piece and the magnet. Man, those are hot enough to cook on. When you got even just a 500-watt speaker, and if you get those big 2,000 watters, that's a lot of heat that you're generating, and it does stay in the motor core. So you're venting the coil, but the coil is surrounded by this super hot, well, kind of like the commutated motor, super hot thermos bottle of a magnet and pole pieces. So it's like, well, okay, there's the answer. Then I made a cooling plug, and the cooling plug attaches to a heat sink, and you can use convection if you want for that, but it didn't matter. I found that too. So I put a plug in it. You machine the pole piece so it's smooth, like a brake cylinder, and then the plug is like a brake piston. It needs to fit in there very perfectly so that you have a good thermal interface. It can't be too snug because the way I do it is the two woofers are pointing in, and the plugs go in each of their pole pieces, and then the panels are connected, and that then becomes a heat sink. And I found that you don't really need airflow because the heat sink does enough, and it really worked. I mean, it gave me over 200% improvement in thermal capacity. I could take a woofer that I would smoke. I could test it. I'd turn it on, run it up, 10, 15 minutes of 400 watts. The voice coil is open. It smoked it. And I could put this cooling plug and plate on there and go to like 850 and be continuous. It's like, that works. It still has the venting because the plug has holes in it. So the venting still works. You're just adding to that. That thing works so good, I patented. And then the last thing about this big monster subwoofer was that I would run those woofers in push-pull drive. The pressure, a positive pressure from, you provide a positive voltage. The positive pressure on one woofer is coming off the front and it's coming off the back on the other one. And that push-pull drive then reduces it reduces even harmonics. So there were three things that sub did for me, the 12 pi bass horn subwoofer. One is the bigger mouth area made it smoother. Two is the cooling plug and play doubled its power capacity. So you ain't going to smoke them as much. And then the third one is push-pull drive reduced even distortion, even harmonics. Well, so now think about it. A bass horn sub is basically run 30 to 100 hertz. So the lowest frequency that you're going to hit this thing with, you're going to low pass it at 30. You're not going to give it frequencies where it's not loaded. So the lowest frequency you can hit it with this is 30 hertz. The second harmonic of that is 60. You don't have that because you're push-pull drive. That's greatly reduced. The third harmonic is 90. Now you're going to have that, but you're so close to the edge of the pass band, you're rapidly coming out of it. By the time you hit 35 hertz? 35 hertz would be second harmonic is 70 and third harmonic is 105. So by, 30 to 40 is the only range that you're going to get any distortion at all. And that would have been the third harmonic, which is rapidly rolling off. By the time you get to 40 and up, you can't have second because push-pull drive, and you can't have third because it's out of the pass band. The folds are actually attenuated. And this thing was a steak piece. I just loved it. Bad thing was it's really hard to build. It's got all those. Typical horn. You got lots of angles that you got to cut, lots of pieces in there. The cooling plug has to align perfectly. For a long time, I was making them on a CNC machine. I've stopped doing that because it's just a lot of work. If somebody just really wants one, I still hand out the plans. You can build them. I did build the prototype by hand. It can be done. It takes a lot of patience. But sorry I've rambled so long. I hope it was interesting for you, my history. I think the point with that last little bit on the pro sound stuff is I would like our show, our little Lone Star, to address the pro sound people. I'd like to bring them in. There's some really good talent there. And a lot of them are DIYers at heart. I do still want to embrace, of course, the small shops. That's who Lone Star is for. The companies like Pi Speakers. They make a product. They're passionate about it. They make it as perfect as they can. And that guy will always have a place at Lone Star. But then I like it when we can bring the audio jewelry. You know, people love to see that stuff. The price is no object. But I mainly on this talk wanted to tell you about Pi speakers. I've told you about the line, the 1 Pi through the 7 Pi. I told you then about my 12 Pi horn sub. And so I think I've told you pretty much everything that I know. Hey, thanks, guys. Thanks for listening. And I hope to see you at the next Lone Star Audio Fest. And if you need to reach me before Lone Star, the easiest way to find me is Wayne at PiSpeakers.com. And that's spelled WAYNE ampersand PiSpeakers.com. All right, guys. Thanks a lot. See you next time.